Alright, this is the last question for chapter 2.11. Two drop balls. So this is actually a really cool question because it really tests your understanding. So, 4H. Alright, so it says a ball is dropped from rest at height 4h. After it has fallen a distance d, a second ball is dropped from rest at height h. What should d be in terms of h so that the balls hit the ground at the same time? So basically we have one ball here and another ball here. They both don't have initial velocity, so this is going to be y is equal to negative half g t squared plus 4h, and this is going to be y is equal to negative half gt squared plus h. So, if we want to find the amount of time it takes for this to basically reach 0, then we make this equal to 0, because that's basically the height of it, right? Once the amount of time we get. So we can just put this here, make it positive. 2h over g rad. Alright, so at that time, it has to be positive because time can't be negative in this case. Alright, so we can plug this in here. Actually, automatically when I see d, it kind of gives me a hint, because when I'm given when I'm trying to find a distance, right, I can use the equation vf squared minus vo squared equals 2ad, and then from there I can actually kind of solve this. Vf squared, as we know, the final velocity, that has to be something. You don't know yet. But Vo squared, we know it has to be 0. Because both these balls are at rest. Right? So Vf squared is equal to 2ad. Really, the acceleration is actually g. And if we square root, we get Vf is equal to 2gd. So we can actually modify this equation because this is not technically right. We want to have negative half gt squared because the acceleration is still constant plus this. Why, you might ask? Because at this point in time, we now know the velocity. And so now we can actually have a better actual equation. So we have 2gd times time. Right, that's our velocity times time. And then plus the 4h from earlier. But we want to minus the d because we're starting at a different height now. It's our new equation. So now we have a little bit of a better perspective. If we want to solve this, we already have the time actually, because we know how much time we need in order for us, how much time that there is for this thing to fall, and we also know that this has to be equal to 0 because we want both of these bodies, both these balls, to hit the ground at 0. So we have 0 is equal to negative half g, and then 2h over g. I put 2h over g because I square rad 2h over g, which is just 2h over g for time, plus 2gd times rad 2h over g plus 4h minus d. Oh, actually, hold on. This actually should be rad 2gd. Just realized. Yeah, it looks way better. Alright, so there's actually a little bit more we can simplify with this. Take out the g's and 2's, so we have negative h plus 4h minus d plus rad 4gdh over g. Cross out the g's. Now we have 3h minus d plus rad 4dh over g. Oh, actually no, there's no more g. Just 4dh. And then from there we can actually, it's a little bit ugly, but it's fine. Because we want to be able to basically get rid of this radical, so we're just going to square it. Isolate. So if you only have one radical, the best thing that you can do is square it. 4dh is going to equal to 9h squared minus 6hd plus d squared. And then from there, we're going to minus the 40h, so we can get a quadratic. Believe it or not, this is actually not factorable because it's super ugly. No offense. So you're gonna use a quadratic formula. By the way, in Morin's book, you should get used to the quadratic formula. It comes up a lot, and just in general, it's really helpful for trying to get the possibilities for your quadratics. It actually has 2 roots, and I'll go over them actually very shortly. So there's negative 10h plus or minus the square root 100h squared minus 4 9h squared. That's actually the c if I have the a, and then the d, which is just 1. 2, and this is the coefficients, remember, so this is going to be 2a, which is just 1. So this is equal to 10h plus or minus the square root of, if you actually simplify this is 36h squared minus those, and you get 64h squared over 2, 10h plus or minus the square root of, or actually, it's just 8h, because I feel like it's pretty obvious. 64 is 8, h squared is h, 2. So now we have 10h plus or minus 8h over 2. That gives us 18h over 2, or, sorry, it's really ugly, or 2h over 2. So it's either 9h or h. Let me think about this. We started off with 4h, so there's no possible freaking way that d could actually be 9h. So not possible. So we only have h. That's the correct answer. Now this is actually a completely new method that's not even in Morin's book. So if you want to look at his method, it's right there. This is the way I would solve it. Definitely more complicated than he probably intended, but that's the algebraic approach.